All right. Good morning, everyone. Today we're going to be talking about intermediate OOP. Now, when we talk about intermediate OOP, and especially today, we're just going to be talking about the difference between class instances and then the class itself, right? And what I mean by that is that a class instance has different capabilities than the class itself. So there's such a thing as class attributes, as we saw this morning in the example code that we looked at. Those class attributes can apply to every single instance of that class, right? Whereas an attribute of an instance only applies to that instance itself. So today's going to be fairly simple. We're going to look at a couple of examples, and then after that, we're just going to rinse and repeat. Do it over and over again to get that muscle memory going and understand the different concepts of what a class can do and what an instance can do, and where do they apply. So in overview today, we're going to be talking about intermediate OOP. We're going to be talking about instance versus class attributes, and we're going to talk about instance versus class methods. All of these concepts will be tested on assessment 1 at the end of this week. All right. Does anyone have any questions over anything that we will be covering? Okay, great. So here we have some classes versus instances. So when you think about OOP, just think of like a huge organization, right? And that organization or that building is a class. And everyone that lives inside of that building or every office within that building is an instance of that class, right? Maybe they all have the same office or that office looks somewhat the same for the people who are there in the WeWork space. You guys know that every single WeWork area looks almost exactly the same as the next one, right? Some are a little bit bigger, some are a little bit smaller. They have minor differences, but the consistency stays the same as far as layout goes. Well, it's the same thing here in OOP, right? You have a building, which is the class, and then every single small office is an instance of said class. All right, and then we talk about class attributes and methods. Well, the class, which is the entire building, can be accessed by every single instance. So if we think about it in that perspective, for the people in the WeWork space or people who are just in common areas, right? You have your own office where you go to work, but then afterwards, if you go to lunch, maybe there's a cafeteria that's offered inside of that building. Well, every time you go to that cafeteria is common to every single office that's working there. So that's something that belongs to the class and not the attribute, right? And then here we have instance attributes and methods can only be accessed by the instance. So that's your personal job stuff, right? Your whiteboard, your computer, the things that belong to you and the functionalities that you do and the job that you apply. Well, that belongs to the instance. It's unique to yourself and it does not affect the class itself. It only affects the instance. Does anyone have any questions over anything I just said?
Just real quick, Francisco.
Mhm.
So the instance attributes and methods can only be accessed by instances. So what can they not be accessed by?
By the class. So the
By
class
the class.
can't access the instance attributes, but the instance can access the class attributes.
Got it. Okay, thank you.
Of course. Okay. Can anyone explain to me what is unique about class attributes and what the difference between class attributes and instance attributes are? Yeah, go ahead, Matt.
Class attribute is like a value that's shared amongst all different instances. So like back to that office building, we could be a company that has like 5 different office buildings, which is an instance of our, like, maybe we have the same layout plan or building we always use. But then we all want to connect to the same database. So maybe the class attribute would be that database. So we have 5 different instances all connecting. So pretty much just lets us share data.
Yeah, that's fantastic. That's one way to look at it. Awesome. Thank you so much, Matt. All right, well, let's go ahead and take a look at some code then. So as we just talked about it, today we only have 2 subjects that we're actually going to cover, class attributes versus instance attributes. And then we have class, instance, and static methods. Static should be a new concept and honestly a complicated one to explain. And that's why we're going to leave that one for last. So let's go ahead and go into some practice. For practice today, let's just make a, oh wow, I have a couple of files open over here. I apologize. For practice today, we're just going to simply make a, I don't want to go with the same dog example that we did yesterday. So maybe we could do something for like a school, right? Or students, like we already practiced yesterday. So let's go ahead and make a student class really quick. I'm going to make my class student. It's not going to take in anything. I'm going to start an init method. It's going to take in self. It's going to take in name, ID, and let's just go with email. We'll leave it there. So now I'll go ahead and make my name variable. It's not going to be privatized. I am going to make the ID privatized, and I am also going to make the student email privatized. Okay, so next we need getters and setters. Can anybody walk me through making a getter and a setter for the ID?
At property,
do def ID and then self.
Okay, ID so that I know it's the getter. Okay.
And
return, oh, go ahead.
then, I would just say, yeah, return the self underscore ID.
All right. So that covers our getter. What about a setter? Let's see. Who do we have? Frank, how do I start the setter? You're muted in case you're talking.
That's my bad. So it will be at get ID dot setter.
All right. And then Eric, oh, go ahead. Eric, can you walk me through finishing the setter?
So you'll have a new method like def what is it, new ID? We just call it that.
So
With the inputs of self and a new ID. And then you could set some kind of a, I don't know if you want to put any parameters in, but ultimately it's going to be self, the self dot underscore ID equals new ID.
So I'll just say if new ID dot is numeric, then you said self dot underscore ID is equal to new ID.
Yes.
Okay, great. So that takes care of our getters and setters for the ID, and now we just need one for email. So let's see, who do we got? John, how do I start the getter for the email? And actually just walk through the entire getter.
For the email,
Yes.
just do add property and then do the same with the one that just copy paste. No, I'm kidding. Def get email, then self, then return self email.
All right, awesome. And then Caleb, could you walk me through creating the setter for this?
Yes. So you do at get email dot setter, and then def set set email self, and then new email, and then if if email has at gmail.com.
Okay, got it. So if actually let's just make it student.org in okay, so now self.email is equal to new email. All right, so now we have our getters and setters for all of our privatized variables. That's completed. And we've created our student. But maybe we could give our student a couple of methods, right? Maybe we can make our student be able to study or do something along those lines. So let's create a method for going to school. And let's create a method for studying. All right, so now for that, anyone want to volunteer for creating either of these methods? All right, Kate, can you walk me through creating the going to school method?
Sure. So I guess you'll just start by writing def go underscore to school, and then in parentheses self, because we want each individual student to be able to go to school instead of like all of them at the same time, I'm guessing, for this.
Right.
And then I don't really know what we would have it do. I guess we could just return like a formatted string that has self dot name goes to school or something like that.
Nice. Okay, fantastic. And then could I get somebody to walk me through the studying method?
You create a depth start studying method with self as a parameter. And then do you just want to return a string? We do that, just return an F string, and it says self.name is starting this study.
All right. So now we have some methods, we have some attributes, we have some getters and setters. But when I make an instance of this class and I go to print it, am I going to be able to see anything specific, or am I just going to see a memory space?
Memory space.
Okay, awesome. So how do I change it so that I can see something specific about this class? Matt Lewis?
Sorry, could you repeat that?
Yeah, of course. So right now, if I create an instance and I print the instance, it's going to show me a memory space. And I would like to change my class so that instead of showing a memory space, I can see something specific about the class instance.
So we'll do a dunder method. So we'll under the def init, we'll do def underscore str underscore and parentheses we'll put self, and then we'll return f string and we'll do curly brackets name or self dot name get name.
Yeah, we privatize it. So yeah, name.
All right. Self dot name, and then we'll do like a ID colon, curly bracket, self dot ID, and then email, colon, curly brackets, self dot email.
All right. Fantastic. Looks like we have our entire class set up now. Okay. And maybe I can make this a little bit smaller. How's that for everyone? Can everyone still read this code? Okay, good. All right, so we have our init method, we have our dunder method. We're utilizing our getters in our dunder method, which is good. Here we have all of our getters, we have our setter. For organizational purposes, it kind of depends on what you want. I like to have my getter and setter next to each other for each individual property or each individual attribute that I'm doing it for. Some people like to have all of their getters and then all of their setters, but for me, that's a little weird. So I prefer doing it this way. And it looks like we have two methods that belong to the instance. Okay, great. So now we've made all of our student methods. Our student class actually exists. So let's make an actual instance of the student. So I'm going to go ahead and copy this init. And actually, maybe we should create a different file here. Okay, so how do I create a new student? A new student instance here.
Student 1 equals student, and then parentheses, their name, ID, and email.
All right. So what name do we want them to have? I guess it doesn't matter. Oh, go ahead.
Joe.
All right. And then we'll just say the ID is 1, and we'll say the email is joe@student.org. Okay, so now let's print student 1. Okay, so now when we go to print out Joe, we can see that we have a name of Joe, we have an ID of 1, and then we have an email of joe@student.org. Okay, so this is great. This is a good review of what we did yesterday. We were able to create a class, we were able to give it some instance, some methods, and attributes. We covered a lot of ground so far, and we did it rather quickly. So before we continue pushing forward, does anyone have any questions over anything we just did? Okay, it looks like there are no questions. So let's go ahead and move on, right? So this is great. I was able to create a student. That student has an ID, and Joe has a student. We have all this information working correctly. But now I guess my next question would be, right? Who was it? I think it was Matt. Matt mentioned that we essentially want to have a shared database as a class attribute, right? So right now we have a student, but what if this was a class that kept track of a student registry, right? We wanted to keep a record of all of the different students that are attending this school. So if I think about that, I would want a way of tracking the student ID. And then by that student ID, I would want to be able to grab a student out of that out from my menu or my program, whatever it is that I'm coding, right? So maybe here under class of student and before the init method, I can create an attribute, and I can name this attribute all students, right? So now in this attribute, what I can do is every single time something gets created in here, I can add it to a dictionary. Now in that dictionary, I can have a key where the ID is the key. And then I could just simply add one every single time the student gets created, which I think that's what who was it? Sean was demonstrating this morning. So maybe we can have a variable ID in here and make that equal to 1 by default, right? So then we could remove ID from here. Still leave our email. We could remove ID from there, or actually, we don't want to remove ID. We just want to make ID, and actually let me make this into 0 and make that equal to student.id. All right, because now I'm referencing the student class and grabbing the variable of ID within it. Okay, well, now let's make sure that ID gets added 1. So student.id plus equals 1. So now when I go to create an instance, it's going to access the student class, access the ID, and then it's going to add 1 into it. All right, and that's how we're going to create our student class. So let's make sure that works up to this point. When I run this, looks like I get an error, and that's because I'm still passing a positional argument that it's no longer taken in. So let me erase that. Okay, and we see that everything still works. Joe still exists. The ID of 1 is still being given to Joe, and Joe at student.org is the email. Now, how could I add Joe into a dictionary of all students? If this is where the logic is running to add 1 to the number of IDs, how could I add a student into this dictionary where the key would be the ID and the student itself would be the value?
In the init, would you do like student dot all students and then just add it, I assume? Yeah, self dot name or ID. And then just equals self.
Yeah, let's try that out. Let's see. So it looks like when I run it, it's able to work correctly. And remember, an instance can access a class attribute, right? So maybe I can print student1 dot all students, right? Because it's an instance accessing a class attribute. So now when I run this, we can see that there is actually inside of this student dictionary, we can see that there's actually a key where the ID is equal to 1. And here we can see that there's a memory location, and that's okay. If I wanted to iterate through it and actually print out the students, I could, once I go to print the value, that's where my dunder method will be triggered, right? Since I'm not printing the value, I'm printing a dictionary, it's going to show me the memory space. Now, currently right now on line 6, I'm accessing all students through an instance. What if I wanted to access all students through a class? What would I need to change about line 6?
Instead of student 1, you just do the student with the capital S.
Okay, so let's change that. When I run it, I still get the same result. Awesome. So now we can see how these two attributes belong to the class, but they're available to every instance, right? If I go to create another student, again, let's say I make student 2. Make that equal to another student. Let's say the student is Francisco. And for purposes, I'm just gonna make it this. Let's have this one be Adam. Okay, so now when I run my program, we're going to see that our dictionary now has 3 keys inside of it, or 3 key value pairs. each one holding each individual instance. I can iterate through it. So let's say for student in student dot all students, we're going to print student dot all students at student. Okay, so we see the first print statement that's happening from student one, which is confirming everything is happening. Our second print statement is just printing our entire dictionary, right, which is showing us all of the students that have been placed inside of the class attribute, which is a dictionary, and it's acting as a database for us. And then after that, we're iterating through that dictionary so that we can print all of the values. And now when I print all of the values, that's when the dunder method is being triggered. Again, in the dictionary, I'm printing a dictionary, so it's showing me memory spaces for each value. But once I iterate through it and I'm actually printing the instance, that's when my dunder method is being triggered. Does anyone have any questions over anything I just covered? Go ahead, Josh.
Can you go back to the attribute you set in the init? Just wondering what we did there with like that last one, student dot all students.
This one?
Yes.
Okay. Yeah, so here we're accessing the all students dictionary. All right, we're calling that dictionary. We're giving it a key, which is equal to this instance ID, which we're setting up here. All right, and that's how we're getting this 1, 2, and 3 location being placed in there. And then we're giving it the value of self. And I'm saying that that value or that pair, that key value pair, so the key being the ID, the value is the entire student instance. And that's how we're building this dictionary right here.
Okay, thank you.
Of course.
I have a question as well.
Yeah, go ahead.
So, and you can stop me if you're going to cover this later, but is there a method you could add to like streamline adding students rather than creating a variable every time?
There definitely is, yes. And we will go over class methods and instance methods here shortly.
Cool.
Josh, do you still have a question or is your hand just still up? Okay.
No, I'm
Okay,
good.
finished. Okay, awesome. Any other questions? Go ahead, Eric.
So hold on, let me make sure I'm going to say this right. For the student class, we made the all students class variable. And now to access all of the student instant variables that we made, we would have to make sure that we, I guess, like instantiate them first for them to be pulled, correct? Like there's like a hierarchy of order we have to do it in to get all that data, if that makes sense.
Right, you have to make instances first, so you have to instantiate a couple of instances before they actually exist within the
Okay.
Awesome. Joshua?
I don't really know how to word this, but how is the all students dictionary being saved? Is it almost as if, like say in another file, you could just have a dictionary and you can like manipulate that dictionary from another file? Is it almost like it's that within the class? If you know what I'm saying? Like if we're not instantiating the class, how is it that we can access data from it?
Yeah, that makes sense.
Okay.
So basically, as soon as I run this file, right, which is runner.py, I'm importing the student class. So that's the first thing it does on line 1. It brings in the student class and it brings in all the information from the student file that we created. All right. So once it imports it, student, the class itself, even though an instance hasn't been made of it, the class exists. Right. I could print student at the very top of this. And let me comment everything else out. Oh, hello. That's not what I meant to do. Yeah, I can print student. And when I go to print student, we're going to see that it gives me an actual memory space. It tells me, hey, this class exists in the file practice, and it's a class named student. So that already exists. And the memory is being allocated to create all of the attributes inside of it, meaning all students in ID exist now, right? That's being tracked within this file. As long as this file is running, those two attributes now exist. So now when I go to instantiate those classes, that's when those changes get made to the student class. But it exists until the file stops running. Once the file stops running, everything gets dumped and completely deleted from my memory space. It's called caching, and Python does that for us automatically.
Okay, so it pretty much loading it in, like triggers it to
Into
into existence. Yeah, I guess I don't know the terminology, but okay, that makes sense. Thank you.
Of course. Go ahead, Brian.
Just to kind of see if I get how the data is being accessed. If on line 10 there, you were to, after you have student, do bracket name, would then it just iterate through the names?
Yeah, I wouldn't do bracket name, right? Because this right here is showing me an instance. Instead, I would do dot name.
Dot name, okay. Cool, that answers my question. Thank you.
Okay, perfect. See a couple of things in the chat. Let me see. Googling what instantiate means here. Okay. All right. Any other questions? Okay, this seems pretty straightforward and pretty simple. Oh, go ahead, Matt.
What happened? So I'm kind of confused with on line 10. If you just turn that whole print statement into student, would it show the memory address or like throw an error?
If I just turn this into student?
Like even like without not the class, the like what you're calling in the for. Like the for student and student. Yeah, like if you just did that, what does it print? I'm just curious.
Yeah, that would just show me the keys.
Okay. Gotcha. Okay, so okay, gotcha. Thanks.
Of course. Okay. So now we understand how we're building this, essentially a database, right? We're building a dictionary with key value pairs. That key is going to be the ID or the primary key, as we'll learn about databases here shortly. And then afterwards, we have those instances attached to them. So now we're able to actually create a program that will be able to take an input from someone, and then it's able to create students. And as more students come to the school, we can add them additionally into the database. Yes, there is such a thing as a representation method. Oh, really? That will change how it's displayed in dictionaries. Huh. Let's try that out. It does change how it's displayed in dictionaries. Would you look at that? Nice. So it looks like the representation method also affects when it's nested within another data structure, while the string method is only taken into effect when you call the instance itself. That's a good one. Thanks, Megan. Okay. We've been going on for quite a bit. If there are no other questions, I think this is going to be a good natural stopping point before we move on to our next subject. So let's go ahead and take a 10-minute break, and then we'll come back at 9:42 or 9:43 now. Let's just make it 9:45 to continue our class. Thank you so much, everyone. Okay, welcome back, everyone. So just before we left, someone asked about a method that we can do to streamline all of this, right? And I was looking at the exercise that we have in between the two portions of our lecture today. And I think it's a good idea to show maybe how that method would look for an instance method, right? So currently we have all this information. We figured out how to place a student into the registry. But what if we wanted to create a method or create a function that would add a student, right? Maybe we want to avoid methods as of now. What can we do here? Yeah, let's make a function that can create a student, right? So we'll make a function here and we'll call this create a student. Now this function is not going to take in any parameters. It's just going to simply start asking questions, right? So we know that we're going to need the name, so we can make the name be equal to input student's name. We can make the ID be equal to I'll have to create another function for that one. So if select. Oh, actually, we don't need ID anymore because that's automatically generated. Would you look at that? So actually, I just need email. And the student email should just be the name plus .org. So let's just say name plus student.org. And then after that, we'll just create a student, right? So we'll say new student is equal to student, where the name is being passed in, and then the email is being passed in. And then right after that, we could just print student dot all students to see how that looks. Well, let's run the script. Oh, probably want to call the function. That makes sense. So now when I call the function, oh, go ahead.
Sorry, do you want to @ as well?
Oh, right here? Yes, I do. Definitely. So let me kill that terminal real quick. Okay, so it's going to ask me for the student name. Let's just say Francisco. Okay, and we can see that everything was streamlined. It was able to add the new student. So we see Francisco. For the name, the ID is 1. And we have Francisco at student.org. Okay. That should be it as of now. This is all we should need to see to be able to do the exercise with the car manager this afternoon. So now what we're going to do is we're going to break up into groups. I'm going to open up some breakout rooms. And then for the next, we'll go for 30 minutes. And if after 30 minutes, the majority of the class is still not done, we'll maybe stretch it out to an hour just to make sure that we're able to get through this exercise. It's just a car manager exercise. In case anyone needs a link to it, let me pass it on here in the chat. Okay, there's the link to it in the chat. I'm going to stop the recording now. All right, welcome back, everyone. As I just previously stated, we're going to go ahead and cover the difference between class methods and instance methods. So far, we talked about how to import student. We'll be able to create a student. We talked about the difference between this class attributes and our instance attributes and how each instance is able to access a class attribute. All right, well, that's great. Now let's talk about some methods that we can create for the class level. As we see here at the bottom, we already have some methods that we created at the instance level. And although the class could try to access these, it would fail because a class doesn't have access to self.name, right? So if we try to take a look at that, if we can say student dot go to school, and I try to run this, we can see that it's going to fail. And it's telling me, hey, yeah, this method does exist within the class, but it's missing a positional argument. And that positional argument is self. It's saying this is not something that we can run without an instance. Well, how do we fix that? And why would I want to fix that? Why would I want there to be something that applies to the entire class rather than something that applies to just an instance itself? Well, so far we created this all students dictionary where we can register all students. Well, maybe I want a method, right? Because earlier we created a function that would be able to create a student. But what if I want that to be a method, right? What if I go to create a student? So let's make a method, create a student, or I guess add a student would be a better terminology. So add a student. Okay, now this is going to be a class method, right? And since it's going to be a class method, rather than utilizing self, I want this to take in CLS. Now, CLS and self, when it really comes down to it, they're just placeholders, right? They don't actually mean anything. They're just placeholders. And we want to follow the, I guess, common architecture where we utilize self for instance methods and we utilize CLS for class methods. That way, any other developer that takes a look at my code can understand, oh, well, this is utilizing self. So this is obviously an instance method. And this is utilizing CLS. So this is going to be a class method. All right. So I plus my colon and I go ahead and start taking in the arguments that I need, right? Which in this case, it looks like all I need is name. So let's say name is equal to input student name. Tab it in to give it a little bit of space. And then once that's inputted, I can just make the email be equal to name plus @student.org. That should give me my email. So now all I need to do is say CLS, and I'm going to pass in name and email into it. And then maybe I could do a print statement where I say, I don't know, maybe I do something like CLS dot all students. That way we could just see that dictionary being able to print out at the end. Well, now I'm going to assume that because I created that, when I run add a student, that function is going to be able to show up in my terminal. All right. So now I run it and I still get an error that's very similar to the last one I got. I got still missing one positional argument. Can anyone tell me why that's happening? Go ahead, Matt. You're muted.
Oh, my bad. I thought I unmuted. I think it's because it doesn't really know like what CLS is referencing at this point in time because it's not using that like self keyword. So we have to kind of give it some idea of what to do with that CLS.
Yeah, perfect. That's fantastic. Right. If we take a look at these two methods, their actual structure is still pretty much identical, right? And just like I mentioned, self and CLS are just placeholders. So if I try to run this code right now, it's going to assume that this is still an instance method. And it's telling me, hey, I'm missing a positional argument because this is not an instance. Well, that's where I tell it that this is a class method. And I do that by giving it a decorator stating, hey, the following function is going to be a class method. And now when I run this function, we can see that it actually works, right? I run my runner. My runner is only adding a student. So now it's asking me for a name. I can input a name here. Jesus, as soon as I can type. And after I input a name, we can see that it prints out the dictionary. All right. Notice that instead of using student with parentheses and then placing in the arguments that I needed, I just called CLS because CLS is no longer referencing to an instance. It's referencing to the entire class itself. So I'm able to create a student through this method. Does anyone have any questions over what I just did? That looks good, Kate.
Yeah, I'm sorry. I had a Zoom problem. Would you please just briefly go over that one more time?
Of course. Yeah. So basically and by over that, do you mean the entire thing or do you mean a specific portion? At which point did I lose you?
It's basically as soon as you started writing the add a student function as a class method, my Zoom had to restart.
Okay, absolutely. Yeah, no problem. So when we go to create a method that's going to be a class, we're going to follow almost exactly the same syntax. We're going to define a function, but because it's within a class, it's called a method. Small difference is that instead of utilizing self, we're going to utilize CLS. Now, self and CLS are just placeholders. but it's common practice to utilize CLS for class methods and self for instance methods. That way, any other Python developer that takes a look at my code can look at it and immediately say, oh, okay, well, this is going to be a class method and CLS is in reference to the class, right? After that, this method will take in an input and it'll create an email. And then I'm able to reference CLS, pass in the correct arguments in order to create an actual entry into my all students dictionary. Now, when I run this function, it gave me an error, and that's because I didn't have the @class method decorator. CLS and self were just placeholders. So they don't tell my method that it's a class method or that it's an instance method. We just utilize CLS and self for other Python developers to be able to look at that and say, oh, this affects the class or this affects an instance. What actually turns this entire method into a class method is the decorator on line 43 of @class method. Does that make sense, Brian? I think you said yes. All right, I'll take it. They see the thumbs up. Okay, great. So now we have I see a question. Go ahead, Matt.
So like in the car manager thing where we were adding a car, this is like the same thing, but with the student.
Exactly. Yes.
But you're keeping it inside the class.
Right, because I want that behavior to be isolated to the class, right? If it's something that's going to affect the class, I would want the behavior to belong to the class. Otherwise, I'm not following the single responsibility principle, right? Anything that I want to isolate behavior as much as possible. So if I get a problem, I can get to it. Does that make sense?
Yes, thank you.
Of course. All right.
Francisco, could you just switch to your practice file real quick? I just wanted to take another see what you did there.
You mean this one?
Yep.
Okay.
Okay. And then what is it going to do once you run it there?
Once I run it, I'm going to receive an input here saying student name, and then I'm going to input a name, and then it's going to print out the dictionary with the entry of the new student.
Got it. Okay, thank you.
Of course. Okay. So now let's say that I wanted a class method that would list all of the students inside of my dictionary. How could I build that method? I'm gonna have you guys walk me through it. So here's an example of what a class method looks like. Now I just need a class method that iterates through the values of a dictionary and prints them out onto my terminal.
Start with the class method.
All right.
You said you want to see all students?
Yes, all the students within the dictionary.
So def view all students or view students, something like that. Parentheses CLS. And then you would just do for student in whatever our dictionary is.
So
okay. For student, all students, colon. And then we're just printing. How do we do that? What is it? All students, brackets, student.
Okay. Now this all students shows up as a yellow squiggly.
We've got to create it.
Find. Say again?
We've got to create that as a dictionary.
It does exist as a dictionary.
Okay.
You've got to prepend it with the CLS dot.
See. So CLS dot all students, and then it prints out the student. Okay. Awesome. So let's do a couple of students then. All right, so let's pull up the terminal here. Let's clear it. Let's run it. All right, the first one's going to be Francisco. Then we have Adam, and then we have Sean. Why not? Okay, so now we see this is the final one, the final print statement coming from add a student. It has 3 of them. And then afterwards, it iterates through the dictionary and it's able to print out each individual student. And that's coming from line 7 of view all students. Nice. This is great. I wonder if I could do this. Okay, that works as well. So I want everyone to start getting a little bit more comfortable with dictionaries. Dictionaries are going to be a pretty complex data structure that we're going to be working with pretty much the entire time while we're in this program. So instead of accessing everything through keys or trying to do square brackets, please start utilizing methods like dot values, right? That's only going to pull out the values that are inside the dictionary. Or if you're going to pull something through a key, utilize the dot get method rather than bracket notation, right? Because if we utilize the bracket notation and the key that happens to not exist for whatever reason, we could run into an error and break our program. And if we use a dot get method, rather than breaking our program, we'll receive a value of none. So just start getting a little bit more experimental with dictionaries so that we can kind of evolve our dictionary skills as we move on in the course. All right, but this is great. Now we have 2 class methods. We have two instance methods, and we can see the difference between them, right? The difference is a class method that has to apply to the class. And an instance method is something that's unique. And we know it's unique because it's referencing attributes that belong to an instance and not attributes that belong to a class. Does anyone have any questions about the difference between class methods and instance methods and when you should use one or the other?
Yeah, Francisco, can you just do a quick overview of when you would use one or the other?
Yeah, definitely. So I would want to use an instance method whenever I'm accessing an attribute that belongs to an instance, right? So in these 2 cases here, I'm utilizing self.name. Well, self.name belongs to an instance. It doesn't belong to a class, right? If I look at the attributes up here, we see that self.name is under the init method of an instance, right? Every time I go to instantiate a class, that's when the init method actually gets triggered, right? Whereas class methods are something that should interact with class attributes, right? We see it interacting with the all students attribute. And it does that in both of these, right? Or it goes into creating an entire instance of the class itself. That's when I would want to utilize the class method. Does that make sense?
Yes, it makes sense.
Okay, perfect. All right, so now the last method that we're going to talk about, and kind of where we start getting into muddy waters as to when we should use each one, we're going to talk about the static method. So now the static method should be used as kind of a utility purpose. All right, so maybe looking for a student. What if I want a specific student? Well, that would be a static method. And we utilize the static method decorator to signalize that that's what it does. Now, a static method is kind of unique because a static method is able to interact with both the class and it's able to interact with an instance. Or actually, I apologize. I'm wrong about that. The static method is only able to do functionalities, but it's able to do functionalities that interact with the class and the instance, if that makes sense. So both the class and instance are able to interact with the static method, but the static method shouldn't touch attributes or do anything to change up the values within the class or static methods. So in this case, we have this view all students, right? We're interacting with something within all students, but we're not changing the value. So that would be a good example of what a static method should be, right? We could change this to be a static method here. And I believe when we run this, they should work just fine. So let me see. So as we can see, it's starting to fail because it's telling me, hey, we're taking in an argument, but that argument doesn't exist. Okay, and now it's able to run correctly, right? But notice the differences. In a method that belongs to an instance, I'm able to utilize self because it's looking for an instance that was initialized. In a class method, it's looking for CLS because it's looking for the class itself. Now, when I utilize a static method, it doesn't take in an argument because it doesn't need the class itself and it doesn't need the instance. It's just basically creating a function that's independent of my class, but still living within my class because it's still interacting with the class. It's still utilizing the information within the class, and that's where the behavior should live. Does anyone have any questions about the three methods and when to utilize each one of them?
I'm sorry, could you just iterate over that again? The difference between them?
Yeah,
Or like
that-
why you would, yeah, thank you.
Of course. So again, a method, just a regular method that belongs to an instance. So an instance method interacts with the instance and the attributes that belong to the instance. So here we can see that it's utilizing self.name, right? It's something that's unique. No number of instances is going to have, well, preferably, no number of instances is going to have the same name, right? Or it's going to have a unique attribute in one way or another. So that's when we would utilize a instance method. Now, a class method should interact with attributes that belong to the class or change the value of anything that belongs to the class, right? In this case, we're utilizing it to create a new entry of that class or instantiate a new instance of the class. And then a static method is independent of both. It doesn't need the class itself, and it doesn't need to have an instance already created. It's just essentially a function that's independent of both, but can interact with both. Meaning it doesn't need to have a student that exists or be instantiated, and it doesn't need the class in order for its functionality to run. Does that make sense?
How do we call view all students?
Yeah, so you would still call view all students through the student class, but the behavior of it is independent, right? So I could basically do this, make this do, how do I explain it? So we see how up here on line 44, it takes in CLS. And then we see it on line 47, referencing CLS to create that new instance, right? That's because it knows that it needs the class in order for the functionality to run. It's referencing the class. Whereas down here, it's not taking in neither self nor CLS. Instead, it references student as if it were just a regular function because it doesn't need them in order to function correctly, but it can still reference both of them, right? Now the logic still interacts with my student class, so the logic should still belong and live within the student class. And that's why I need to call it from the student class, even though it's independent. I know I just said class like 100 times, and I probably just kind of repeated myself over and over again in a different way, expecting a different result. So I apologize to everyone, but if anyone needs a better way to explain this, I definitely can try to provide a different angle. Does anyone else? Oh, go ahead, Mike.
I had a different type of question. Back on the other file, the practice. Do we need a static method at static method? Like wouldn't it?
Oh,
you do not.
Keep going.
Like wouldn't, if you got rid of the static method, wouldn't the view all students do the same thing as a static method at that point?
Yeah, so let's try that out. So if I try to run it this way. Exactly. So even though I didn't add the add static method, it was still able to run as if it were a static method.
Yeah.
But that's not proper Python syntax, and you would want to describe that this is a static method.
Okay.
Go ahead, Matt.
So if you make that static method like tag, and then you try to actually like access variables within it, is it going to throw an error, or is it just like that isn't actually doing anything on the program side? It's more for like that tags for other programmers. So it's like if I'm going through, I know, okay, this shouldn't be adjusting anything. So if I see it adjusting, I know it shouldn't. Or is it actually doing something like under the hood on Python when it runs our code?
This tag right here is doing something under the hood. It's what makes it available to exist in other methods, right? So if I go into another method and this doesn't have this tag, I wouldn't be able to access it. Kind of how our getters and setters work, where we have this property tag, and that property tag is what allows us to create a setter for our getter. It works the same way with static methods. Now, I want everyone to know that static methods are not very common, especially in Python. So you don't have to necessarily worry about this. Do try to learn it, but the two that I do want everyone to be proficient at are the difference between class methods and instance methods. Did that answer your question, Matt?
I guess I was more curious if like you said static methods, like they don't access class or instance like values or like attributes. So I was wondering if we have that tag and then we try to do that, is it going to throw an error? So is that like a benefit of using static, is I can kind of brainstorm and say, okay, here's my idea for this function. I want it to just be static, and I can kind of put that up top and then like run it. So if it throws like some type of error, I can like, I guess, is it more a keyword for, yeah, I don't know. I don't know if I'm ever gonna, I guess, just comprehend that. I just have to go read the docs or something.
No, I think I understand your question. So note in here, we're able to access the class variables, right? But if I wanted to do something like access the name, right, that we have up here that belongs to an instance, I wouldn't be able to. And you're right, a static method shouldn't be changing anything within the class. It should be able to access it and print or run some logic to give me some sort of statement. Like if I was running a calculator or something like that, and I wanted this static method to return to me some statistic or maybe the values of all the prior things that I've done, then the static method would fit it, right? Because it would run some logic to give me a result, but it wouldn't necessarily change any values or of the class or any instances. And that's what makes it a static method, that it's not actually changing the values of the class or instance. Did that address your question? Okay, I see a thumbs up. Okay, any other questions? Okay, it doesn't seem like there are any other questions. That's going to conclude our lecture for the day. So in overview, today we covered the difference between class attributes and instance attributes, and we covered the different type of methods such as class, instance, and static methods. At this point, I'm more than confident in your guys' ability to go and apply these fundamentals to complete today's exercises, and that you guys will be able to pass the assessment at the end of this week, utilizing class and instance methods and class and instance attributes. Thank you so much, everyone. I'm going to go ahead and stop the recording.